Hi there, this is Miss Cairo here, and I'm going to do a short review in which I will be guiding you through how to multiply two numbers when they involve place value shifts. So, over here on your screen is some rules with shifting patterns that we have been learning about for during this unit. So, over here on the left-hand side, written in blue, we have whole number multipliers. And when we come across problems with factors such as 10, 100, or 1000, we can use our place value knowledge and this pattern that we've been studying to solve. For example, when we multiply times 10 or times 10 to the first power, those are the same. We know that we can shift our digits one place value to the left. When we multiply by 100 or times 10 to the second power, that means we can take the other factor, we can shift the digits two places to the left to arrive at our product. And when we multiply by 1000 or 10 to the third power, those are the same. We can shift our digits three places to the left to arrive at our product. The same goes when we're multiplying by decimal multipliers of base tens, which are times 10 to the first power, times 1/10, I apologize, times 100th, and times 1000ths. And you'll notice we looked at some patterns that we saw in which these two relate to each other. So times 1/10 is the same in which for 10, we multiply and shift our digits one place, but instead to the left, we go to the right. And when we multiply something times 100th, again, we shift our digits two places to the right. And then times 1000s, our digits are shifting three places to the right. When we shift it to the right, our products are getting smaller in value. When we multiply whole numbers or shift to the left, our products are getting or increasing in value. We also have been following this rule in which when we multiply a factor times a factor and they involve decimals, the total number of decimal places in the factors has to be the total number of decimal places in the product. So here's an example. Remember, what we've been doing is we ignore the decimal places and we multiply as if they're whole numbers. So for 7 and 100th times 2/10, if we ignore the decimal, we get 1,402. Our next step then is to count how many total decimal places are there in both factors. So for this example, there's 1, 2, 3 total decimal places. And then we take our whole number product or whole number answer and we count the total number of decimal places on this side as well. So 1, 2, 3. And we know to place our decimal in front of the place values that we counted up. So on your test, Unit 4 test, you're going to have some problems in which you are going to be multiplying by base 10 numbers. So for example, multiplying by times 10, times 100, or 1000. And you can solve using either your place value shifting rules or the ignoring the decimals and then multiplying out and then adding the decimal places in your product generalization that we've learned also. So there's two ways to solve this. I'm going to walk you through both ways as a review. So what I'd like you to do on your whiteboard, please write out this problem 8/10 times 100. 8/10 times 100. And with the shifting patterns, what we do is I notice that we're multiplying by 100. That 100 is a factor here means I can use shifting to solve. So what we're going to do is we're going to take our other factor, so 8/10 in this problem, and we're going to put it in the first row of our place value chart. So 8/10 written into our place value chart. I'm making sure my 8 is in the tenths place value, just like that. Okay, and now let's use some place value shifting to solve. We know that when we multiply by 100, we're going to shift our places or digits 2 places to the left. That means we're going this direction, and we've been using little hills to move them over. So the digit I'm most concerned about here is our non-zero digit, and it's the digit 8. The 8 is going to move from the 10th spot to the what place value if I'm moving by 2 places? 1, 2 place values. And our 8 is going to move from the tenths to the tens. So I'm going to put an 8 in our tens. And our next step is we need to hold its place value. So we're going to add in zeros until we reach the decimal. So 8 in the tens. I'm going to put a 0 in the ones place value. And we arrive at our answer of 80. Why didn't we shift this 0 in the ones? Well, if I were to, I would have a 0 here. And we know with whole numbers, we can eliminate those zeros until we reach a non-zero number. So 80 is written with 8 in the tens and a 0 in the ones. All right, so on your whiteboard, complete the equation. 8/10 times 100 is 80. Let's try another one. So go ahead and erase your place value chart. You can keep that problem on your whiteboard, though, to refer back to. Let's try something that involves an exponent. Let's do 94 hundredths times 10 to the first power. Again, I see the factor here, 10 to the first power, and I know we can use shifting patterns to solve. 10 to the first power is the same as times 10. So what we're going to do is we're going to write our other factor, 49 hundredths, into our first row of our place value chart. Again, where we place our digits is super important. 4 should be in the tenths and 9 should be in the hundredths. When we multiply something by 10 to the first power, we can shift our digits 1 place value to the left to solve, to get to our product. So we're to the left. Again, we're going to be increasing in place values here. And we're just going 1 time over. So I'm going to use little hills to demonstrate it. Our 4 in the tenths is going to go 1 place value to the left. And the 4 is going to be moved over to the ones then. So I did a little hill and a 4 is now in the ones, and do that with me. And we're going to do that also for the nines. The 9 is going to move from the hundredths to what place value if I shift it 1 to the left? To the tenths. And now we have our answer here of 4 9/10. And we can add that into our whiteboard. 4 9/10, 4.9. And again, there is another way of solving this. We can use this rule of ignoring the decimals and then adding the decimal places in after we multiplied as if they're whole numbers. So let's try that. So keep that problem there, 49 hundredths. Keep the answer there too. Let's solve it in a different way. So if we ignore the decimals here, we would have 49 times 10 to the first power is the same as times just 10. So go ahead and write that on your whiteboard and let's solve. What's 49 times 10? 490. Go ahead and write that out. We're not done though. The problem was 49 hundredths times 10 to the first power. So we're going to count how many decimal places did we ignore in both our factors. How many decimal places are there in our factors? 1, 2 decimal places. So how many decimal places does there need to be in our answer or in our product? 2 over here. So there needs to be 2 in our answer. Well, let's do it. We start all the way to the right. We draw, I draw lines underneath to count. 1, 2, and I place my decimal in front of the last digit that I multiplied, which is in between the 4 and the 9 in this case, and we arrive at our answer of 4 and 90 hundredths. We got that as well up here. These are different in the sense that there is a 0 at the end, but they hold the same value. Remember, we also learned that we can drop the 0. Zeros at the end of any non-zero number after the decimal have no value, and we have the same answer solved two different ways. Okay, let's have you try it again on your own.